Today, we're tackling a really big question, one that seems to define a lot of market discussion right now. What exactly is Tesla? I mean, based on the analysis and the financials you've brought, are we looking at just a very, very efficient car company?
Or is it something else entirely? Maybe the start of a huge, maybe trillion-dollar AI platform, but one that's definitely high risk, high reward.
It really feels like the ultimate corporate identity crisis, doesn't it?
It really does. And the sheer scale of the bet the investment community is making, it's staggering. We're talking about a valuation, recently hovering around $1.47 trillion.
Trillion. It's hard to even conceptualize.
It is. And to give you some perspective, our sources are suggesting this market cap, well, in some ways you could see it as basically the same value as the next 10 biggest traditional car companies all put together.
Wow, so Ford, Toyota, VW, all of them combined.
Stacked right up. That's the kind of multiple we're dealing with here.
Okay, so let's unpack that valuation paradox straight away.
Yeah.
Because the basic data, the actual car sales numbers, they just don't seem to support that kind of figure if you think of them as just a car company.
Exactly. If you look purely at vehicle volume, the classic way you measure success in the auto industry, the numbers are, frankly, kind of humbling.
Right, despite being this huge global name, the EV leader.
Their global market share is tiny. It's only about, 1.2%? Based on maybe 900,000 cars sold back in 2021 out of maybe 75 million sold globally.
But 1.2% market share, you just can't make a $1.47 trillion valuation make sense based on that alone.
You absolutely can't. And that tiny market share, that's really the core idea for this deep dive. Our sources are pretty clear. This extreme valuation, this premium, you look at the PE ratio, the price to earnings.
Yeah.
Normalize, it's sitting at something like 213, just astronomical. Yeah. And it's not based on current car sales.
Not even close.
Not even close.
Yeah.
Or even, how fast they might grow the car business in the next few years.
So if it's not about what they're doing right now, selling cars, what is the market actually valuing? What's that $1.47 trillion for?
It's almost entirely based on them pulling off their big strategic shift. Successfully, on time, and crucially, safely.
So,
the market is essentially betting that they can morph from being just the EV leader into a fully vertically integrated AI and robotics company.
So full self-driving, robotaxis, the Optimus robot, all of that has to actually happen.
It has to happen. And it can't just sort of happen eventually. It needs to happen reasonably on schedule. Because if that AI future, if it stumbles or gets significantly delayed,
the whole valuation rationale just evaporates.
Instantly, it becomes completely indefensible based on the underlying car business.
Okay, let's dig into that pivot then. Because it sounds like a pretty radical shift in what the company's even trying to do.
Yeah.
When you look back at their famous master plans, the focus seems to have changed quite a bit over time.
Oh, dramatically. If you look at the history, master plans, say, parts 1, 2, and 3, they were very much centered on one thing, speeding up the world's move to sustainable energy.
Right, EVs, solar roofs, power walls, the big mega packs for utility.
Exactly, that was the mission. Build the hardware for a sustainable energy future. And success was measured by, how much environmental benefit you could create.
But the latest plan, part 4, it talks about something different.
Precisely. And the ultimate aim, the sort of philosophical underpinning, is to maximize humanity's scarcest resource.
Which is time.
Time. And how do you maximize time, according to this plan? You automate human labor, that's Optimus, and you eliminate the need for humans to drive, that's the robotaxi vision, enabled by FSD.
Right.
So the sources really emphasize that this high-level goal requires the successful rollout of AI, and that immediately changes the role of the car division within the company.
It makes the car business kind of secondary, a means to an end rather than the end itself.
Exactly. It becomes a stepping stone. Now, don't get me wrong, the EV business still brings in, 95% of the revenue today, so it's crucial. But its strategic function now is really twofold. First, obviously, it generates the cash. It funds the incredibly expensive AI projects like the Dojo supercomputer.
Okay, so it pays the bills for the future tech.
Right. But second, and this is maybe even more critical for the AI strategy, it's the data collection engine, a massive, unparalleled data collection engine.
So every car they sell isn't just a car anymore. It's like a sensor driving around.
It's effectively a proprietary data node out in the real world. Every mile driven by one of their cars, with the right sensors enabled, potentially generates unique, anonymized driving data.
Data that traditional car companies just don't have at that scale.
Not even close. And that data, That's the absolute lifeblood for training the neural networks they need for FSD and ultimately the robotaxi. It fuels the high-risk AI ventures.
And you're saying this pivot, moving heavily into AI and robotics, it's not just a nice idea, it's actually required to justify that valuation.
Absolutely mandatory. Think about it. The core EV market, it's growing, yes, but it's also maturing incredibly quickly. You've got intense competition flooding in, especially from efficient Asian manufacturers.
Right, the price wars we're seeing.
Exactly. And that maturation, those price wars, they inevitably crush margins over time. So to keep justifying that sky-high PE ratio, that trillion-dollar-plus valuation, they have to break out of just being a car
I
company.
mean, new markets, huge new markets.
Yeah, potentially limitless total addressable markets, or TAMs, as the analysts call them. That's what AI and robotics represent. If they just end up being a really good, efficient EV maker, well, the valuation eventually has to come back down to earth, closer to traditional auto industry multiples.
So the pivot isn't optional. It's existential for the current stock price.
That's the core argument, yes. It's an existential necessity for the valuation.
Okay, so if the AI dream is what's driving that huge valuation premium, the day-to-day operational stuff, the manufacturing, the sales, and that's what has to keep the core business solid while they chase that dream, right? Especially with the competition heating up. Let's talk about total vertical integration, TVI. That seems like a huge strategic advantage for them.
It's arguably their most significant, most durable competitive moat. TVI means they control pretty much the whole stack.
From batteries to software.
To the charging network, even the sales process itself. Think about legacy car companies, the traditional OEMs. They're often trying to bolt new EV technology onto vehicle platforms that were designed, decades ago for combustion engines.
Right, adapting old architectures.
Whereas Tesla designs everything, the battery management system, the power electronics, the core vehicle software from a clean sheet, specifically to work together as one integrated system.
And that must give them real advantages in just how the car performs and how efficient it is.
Huge advantages. Definitely in battery management, getting the most range and life out of the pack thermal performance, keeping everything cool efficiently, and just overall software optimization. Because they control that hardware-software interface so tightly, they can often squeeze more performance, more range out of a given battery size than rivals who are mixing and matching components from different suppliers.
And that integration goes beyond just the car, right? It connects everything they sell.
That's right. It's a single common software platform that kind of underpins everything, the big megapack utility batteries, the power walls people have at home, and obviously the cars. And this whole system, it's constantly learning, leveraging, over 15 years of their own battery data now, which feeds into machine learning, real-time control algorithms. Think about their energy software products like Autobidder or Opticaster.
Right, you mentioned those. They're not just storing energy.
No, they're actively managing it. These are high-margin software tools that automatically decide when to charge or discharge the battery, when to sell power back to the grid when prices are highest. They're turning those batteries into actively managed financial assets.
That's fascinating. So it's not just a dumb battery sitting there.
Not at all. It's dynamic. And it means they can push continuous improvements through over-the-air updates, OTA updates, improving reliability, tweaking performance, maximizing the economic value of every single asset they have out there.
That level of control, you just can't get that if you're buying core parts from third parties.
It's basically impossible for traditional OEMs who rely on a complex web of suppliers for critical components like battery management systems or powertrain controls.
And that desire for control, that ecosystem approach, that's also why they fight tooth and nail for their direct sales model, isn't it? Which causes all sorts of headaches with state laws.
Absolutely. The direct sales model isn't just a preference. It's fundamental to their strategy. Their argument has always been, look, traditional franchise dealerships, they just aren't set up or incentivized to properly explain complex EV tech.
Or the battery systems, the OTA updates.
Exactly, especially when the traditional dealership model makes most of its profit from service and parts for gasoline cars. High-margin service bays are their bread and butter.
So Tesla's approach, focusing on OTA fixes and mobile service, it basically cuts out the dealership's main profit center.
It completely disrupts it. They want to minimize physical service visits. Their goal is software fixes first, then mobile service vans coming to you. If you look historically, their own parts and service revenue was tiny, sometimes even negative margin early on, which proves the point. The traditional dealer model financially just doesn't align with their product and service philosophy. They don't want you coming in for constant high-margin repairs.
But going direct puts them in direct conflict with all these state franchise laws
Yeah.
designed to protect those dealerships.
Huge conflicts. They've had to fight state by state, Texas, Michigan, Louisiana, many others. Economists often look at these franchise laws, the ones banning direct manufacturer sales, and they pretty much call it what it is:
Which is?
rent-seeking.
Okay, break that down for us. What does rent-seeking mean here?
Rent-seeking in this context basically means an existing industry here. The car dealerships uses its political clout, uses these old franchise laws to protect its existing business model and profit margins from new competition.
So they're using laws to block a more efficient model, just to protect their own income.
Essentially, yes. They're extracting rent from their protected position, often at the expense of consumer choice or lower prices, without necessarily adding equivalent value.
And it's not just a theoretical cost to consumers. The sources you looked at found it actually costs the states money too.
That was a surprising finding. By blocking direct sales, these states are actually giving up significant sales tax revenue they would otherwise collect. One analysis, even before the big Model 3 ramp-up, estimated Texas alone was potentially forfeiting something like $34 million a year in sales tax.
Wow. So the states are leaving money on the table to protect the old dealership model.
It shows you how strong that political influence can be, even when there's a clear financial downside for the state itself, let alone the consumers.
All right, let's shift gears to manufacturing innovation. Because defending those margins, especially with the price cuts, means they need massive cost savings. That has to start with the battery, right? Specifically the 4680 cell.
The 4680 cell, named for the dimensions, 46 millimeter by 80 millimeter, yeah, that's absolutely critical for cost reduction. The big target everyone talks about is getting the battery pack cost consistently below $100 per kilowatt hour.
Which is seen as the magic number for EVs to reach price parity with gasoline cars.
Exactly. Using fewer, larger cells helps simplify the pack design. But the real breakthrough, the thing that's supposed to unlock those savings, is the dry battery electrode process.
Okay, the dry electrode process. They got that technology when they bought Maxwell Technologies, right?
That's right, and that's the big technological bet. Traditional battery making uses this complex, messy, wet chemistry process. It involves solvents, and then you need these huge energy-guzzling ovens to bake and dry the electrode material.
Very energy intensive.
Extremely. The dry process, in theory, gets rid of that whole wet slurry mixing and drying stage. You apply the materials directly in a dry powder form. If it works at scale,
It saves huge amounts of energy, factory space, time.
exactly, massive potential savings. But, and this is a big but,
And it hasn't been easy to scale up.
that's where the execution risk really hits hard. Scaling up the 4680, specifically getting that dry electrode process to work reliably and consistently with graphite, which they use for the anode, it's proven much, much harder than anticipated.
What were the problems? Like coating it evenly?
Yeah, things like ensuring a uniform coating, maintaining the structural integrity of the electrode when it's applied dry, getting the binder to work correctly. It's technically very complex.
And the yields weren't good enough.
The reports indicated pilot lines were struggling, maybe only hitting 70%, sometimes 80% yield. For high-volume battery manufacturing, you need yields way, way higher than that. You need to be consistently above 90%, ideally 95% plus.
Otherwise, you're just throwing away too much material and money.
Precisely. If you're scrapping 20–30% of your cells, you completely lose the cost advantage you were aiming for.
And this struggle, this delay in hitting high yields, it forced them into running two different production lines side by side.
Exactly. They couldn't fully switch over, so they've had to keep using the older, proven 2170 cells, often sourced from partners like Panasonic, while also trying to ramp up their own in-house 4680s.
Which sounds complicated and expensive.
It is. It adds massive operational complexity, ties up capital in two different systems, and crucially, it delays achieving those lower battery costs they desperately need to offset the price cuts and defend their margins. It's a major bottleneck.
Okay, so assuming they eventually solve the 4680 puzzle, the next big manufacturing leap is how they plan to build the upcoming, cheaper mass-market cars this unboxed process.
Right, the unboxed process. This is maybe even more radical than the battery tech in terms of changing how cars are assembled. Forget the traditional moving assembly line where the car body goes down the line and parts are added sequentially.
So what do they do instead?
They plan to build the car in big, self-contained modules, like the entire front section, the rear section, the floor pan with the battery integrated, the seats, all built up simultaneously in different parts of the factory.
And then they just snap them together at the end.
Kind of like that, yeah. A final, much simpler joining operation. It completely changes the factory layout and workflow.
And the claim benefits are pretty huge, right?
Yeah.
Faster, cheaper.
That's the projection. The sources we looked at suggest they anticipate this could be maybe 25% faster overall and require something like 40% fewer people and less capital investment to set up a new factory line.
40% less capex. That's enormous.
It is. And those kinds of savings in both capital and labor are basically the only way they can realistically hit that target of a $25,000 mass market car while still making a decent profit.
And a key part of enabling this modular approach is gigacasting, right? Making huge single pieces of the car's structure.
Gigacasting is absolutely integral, using those enormous high-pressure die-casting machines, the gigapresses, to create massive single aluminum castings for the front and rear underbody sections.
Instead of stamping and welding, what, dozens or hundreds of small parts?
Exactly. Management calls it game-changing. It dramatically reduces complexity, cuts weight, slashes manufacturing time and cost by potentially thousands of dollars per vehicle. It also potentially makes the car stronger and safer.
But whenever you scale up something that radical, that fast, isn't there a big risk of quality control problems, at least initially? We've seen that before with them, haven't we?
We absolutely have. You just have to look back to, say, 2019, 2020, 2021, the early days of the Model 3 and Model Y ramp up. There were plenty of reports, lots of owner complaints about things like inconsistent panel gaps, maybe some issues with interior trim, fit, and finish, early problems with the heat pump system.
Right, I remember that.
So if they had those kinds of QC bumps while scaling up what was still a relatively conventional, albeit advanced, EV architecture, imagine the potential risks when scaling up something as fundamentally different as the unboxed process combined with gigacasting. The potential for initial QC issues seems significantly higher.
And why is that risk particularly dangerous for the upcoming $25,000 model?
It's all about the customer base.
Yeah.
The people who bought the early Model S or even the Model 3 and Y were often early adopters. They were paying a premium, they were excited about the tech, maybe more willing to overlook a minor cosmetic flaw. But someone buying a $25,000 car, that's the mass market. They're comparing it to established players like Toyota or Honda. They generally have much higher expectations for perfect fit and finish right out of the box. They are far less tolerant of imperfections.
So a rocky launch with quality issues could really hurt adoption.
It could severely damage the perception of the car right at launch, potentially undermining the huge sales volume they absolutely need to make the economics of that $25,000 price point work. It's a critical risk factor.
Okay, one last piece on the operational side before we dive fully into AI. The supercharger network. It started as a necessity, but it's become this huge strategic asset, and now it's even becoming an industry standard.
It really is a masterclass in turning a required investment into a competitive advantage. Initially, they had to build it because there was no reliable charging infrastructure, but doing it themselves gave them complete end-to-end control.
Control over the reliability, the user experience.
Exactly. Ensuring it actually works when you pull up, making it seamless plug-in. It recognizes your car, charges your account automatically. That plug-in charge experience is something third-party networks have really struggled to replicate consistently.
And they're not standing still with the technology either, right? They're upgrading the chargers.
Right. They're rolling out the V4 superchargers now. These are capable of delivering, 325 kilowatts of sustained power with plans for even higher speeds, maybe 500 kilowatts or more down the road.
And sustained power is key, not just peak.
Absolutely. Higher sustained power means faster charging times overall, which means more cars can get through the station per hour. It reduces wait times, reduces congestion. It just makes the whole experience better and more convenient.
And then there's the big move, getting other automakers to adopt their plug, the NACS standard. That feels like more than just getting some extra revenue from Ford or GM owners using their chargers.
Oh, it's a massive strategic win far beyond the direct revenue. Yes, opening the network brings in more money, helps utilize the asset better, but the real prize is getting NACS adopted as the standard across North America.
Why is that so important?
Because it forces everyone else onto their physical connector standard. But more than that, it likely pushes competitors towards adopting their communication protocols too, if they want that seamless plug-and-charge experience. It basically institutionalizes their technological leadership and reinforces their ecosystem's dominance. They're setting the rules of the road for charging.
Okay, let's get to the heart of that $1.47 trillion valuation premium, the massive bet on artificial intelligence. And that has to start with FSD, full self-driving. Now, despite the name, FSD beta, or FSD supervised as they call it now, it's still technically classified as a level 2 system, right?
That L2 classification is absolutely critical. It's the single most important legal and, frankly, technological distinction right now. Level 2 means it's an advanced driver assistance system, or ADS.
It helps the driver but doesn't replace them.
Exactly. The system requires active driver supervision at all times. The human driver must be paying attention, hands-on or near the wheel, ready to take over instantly. Yes, it can do some impressive things, navigate highways, change lanes, make turns, even handle some city streets now, up to pretty high speeds, like 85 mile an hour. But legally, ethically, the driver is always 100% responsible. The car is assisting. It is absolutely not autonomous by the standard definitions used by regulators and engineers.
In deploying this advanced L2 system so widely, using customers essentially as beta testers and relying on them as the safety backup,
Right.
that's led to some serious regulatory scrutiny, hasn't it? Which seems like it could directly threaten the ultimate goal of making money from robotaxis.
That scrutiny is a huge cloud hanging over the program. The main U.S. auto safety regulator, NHTSA, the National Highway Traffic Safety Administration, they've launched multiple large-scale investigations. We're talking probes covering potentially millions of vehicles, nearly 2.9 million in some cases.
And what are they investigating specifically?
They're looking into crashes and incidents where FSD was reportedly engaged. There have been highly publicized reports, documented cases, of cars on FSD exhibiting unsafe behavior, things like attempting to drive through stop signs or red lights, making unsafe lane changes, sometimes into oncoming traffic or off the road entirely.
And these aren't just minor glitches.
No. The sources we reviewed highlighted that NHTSA has specifically documented at least 58 incidents involving safety violations linked to FSD use. And tragically, those incidents have included multiple crashes resulting in at least 23 reported injuries.
And when these safety issues are found, it leads to recalls, which has legal implications too.
Absolutely. When NHTSA finds a defect, or when the company identifies a flaw that poses a safety risk, they are legally required to issue a recall. Often these are software recalls fixed via an OTA update.
Right.
But the fact that a recall happened serves as powerful evidence in any potential lawsuits arising from accidents. It effectively confirms the company was aware of a specific system flaw or limitation. This creates a substantial and growing litigation risk.
And that risk, that regulatory overhang, directly impacts their ability to actually make the jump from this supervised level 2 system to a truly driverless level 4 or 5 system needed for robotaxis.
It directly impedes it. It creates this huge hurdle, both technologically and in terms of public and regulatory acceptance.
And this is where we see that big difference in approach compared to competitors like Waymo or Cruise. They seem to be taking a very different path to autonomy.
The difference is stark, yeah. Tesla's strategy is all about scale. Collect vast amounts of real-world driving data from millions of customer cars operating at level 2, across all sorts of roads and conditions. It's the fleet learning approach everyone effectively helps train the system.
While Waymo and Cruise are focused on.
They prioritize achieving true level 4 autonomy. That means fully driverless, no human supervision needed at all, but they do it within very specific, carefully mapped geographic areas, often dense urban environments. They use specialized vehicles with more expensive sensor suites, like LiDAR, which Tesla doesn't use.
So Waymo and Cruise are going deep but narrow. Tesla's going broad, but maybe shallower in terms of proven driverless capability.
That's a good way to put it. Cruise, for instance, before their recent setbacks, had clocked over 10 million fully driverless miles. That's L4 operation, albeit in places like San Francisco or Phoenix. They proved L4 was possible in those controlled zones. The risk for Tesla is that while they have this massive L2 fleet generating data, the safety incidents and regulatory actions happening at L2 make it incredibly difficult to convince regulators, insurers, and the public that the system is ready for the jump to L4, L5, where there's no human backup.
So if they can't make that leap safely and get approval, the whole robotaxi business model just doesn't happen.
Essentially, yes. If they remain stuck at L2, or even an enhanced L2, the dream of a massive, high-margin robotaxi network generating recurring revenue, it stays a dream. The huge potential value of FSD then becomes limited to just selling it as an optional driver assist feature, which is a much, much smaller market than autonomous ride-hailing. The valuation really hinges on making that leap from assisting the driver to replacing the driver.
And to handle all that data coming in from the millions of cars, they've made this huge investment in their own custom supercomputer, Dojo.
Dojo is a massive bet in itself, a huge capital expenditure. It's custom-designed silicon, custom hardware, built specifically to train their neural networks using the video data from the fleet. The goal is raw computational power process, more data, faster, than rivals potentially could using off-the-shelf hardware or cloud solutions.
So Dojo needs to provide a real competitive edge in training speed to justify its cost.
Absolutely. If Dojo just ends up being incrementally faster, or if they run into unforeseen problems scaling it, then that massive investment doesn't deliver the promised advantage. The data itself is valuable, but it only becomes intelligence when you can process it effectively and use it to rapidly improve the AI models. Dojo is key to unlocking the value in that data hoard.
Okay, so FSD and Dojo are about mobility. The third pillar of this AI ambition is Optimus, the humanoid robot. This tackles that other foundational block, labor.
Optimus represents maybe the most audacious part of the whole vision. The potential market size here is just mind-boggling. Some analysts are throwing around numbers suggesting the total addressable market for capable humanoid robots could eventually exceed $5 trillion.
$5 trillion for robots doing human tasks.
That's the scale of the ambition. And management has suggested Optimus could eventually be priced relatively affordably, maybe somewhere in the $20,000 to $30,000 range, similar to a car.
Which is aggressive. And the timelines they've talked about for actually producing these robots seem even more aggressive.
Extraordinarily aggressive, almost unbelievable based on typical manufacturing ramps for complex new products. They've talked about having the first legion, their word, of robots working in their own factories potentially in 2025.
Okay, using them internally first.
Right, but then scaling production for external sales incredibly quickly, maybe hitting a baseline of 5,000, optimistically 10,000 units produced in 2025, and then aiming for something like 50,000 units in 2026.
That ramp-up sounds faster than almost any complex hardware product ever.
It's virtually unprecedented for something this complex and novel.
But let's play this out. If they somehow did manage to hit numbers even close to that, what would the financial impact look like?
Well, if they achieve that kind of volume, analysts start projecting pretty massive numbers. This division alone could potentially be generating, say, $30 billion in annual revenue sometime early next decade.
$30 billion a year from robots.
And more importantly, just the Optimus division, if it looks like it's on that trajectory, could potentially support a valuation of maybe $400 billion on its own.
Wow, $400 billion. That's like 40% of their entire current market cap,
Yeah.
just for the robot.
Roughly, yeah. That's the scale of the bet embedded in the current valuation, that Optimus isn't just a side project, it's a core future pillar potentially worth hundreds of billions.
Okay, but we have to inject some reality here. Given the track record of, let's say, optimistic timelines for FSD and robotaxi actually launching,
Yeah.
how seriously should we take these Optimus production targets?
That's the crucial question. The risk warning here needs to be flashing bright red. These projections depend entirely on, first, achieving unprecedented manufacturing scale at unheard of speed. Second, they depend on the robot actually working reliably and usefully in complex real-world environments, which is a massive technological hurdle in itself. And third, they rely on those extremely bullish market size and valuation estimates panning out.
So lots of things have to go perfectly right.
Everything has to go right. Given the history with FSD timelines slipping repeatedly, investors really have to apply a very significant discount for execution risk when looking at Optimus. That $400 billion potential is enticing, but the path to get there is incredibly narrow and fraught with potential delays and challenges. High reward, absolutely massive risk.
All right, let's pull back from the future AI dreams for a moment and ground ourselves in the financial reality of Tesla today. Because while AI might be the story for the valuation, the actual car business, the thing generating the revenue right now, is facing some serious pressure, especially on margins because of the price war.
The margin erosion has been quite severe, actually. If you look at their automotive gross margin, and importantly, you have to exclude the regulatory credits, which we'll talk about, it's fallen pretty sharply, from peaks that were comfortably above 25%, maybe back in 2022.
Yeah, very healthy margins then.
Down to figures hovering more around, say, 16.5% to maybe 18% by mid-2025, based on projections. That's a big drop.
And that's almost entirely due to them having to cut prices globally.
Almost entirely. They've had to respond aggressively to intense competition, particularly from Chinese manufacturers who have achieved remarkable scale and cost efficiency.
Companies like BYD, you mean?
BYD is the prime example. They've overtaken Tesla in terms of global EV unit sales volume in some quarters, and their cost structure allows them to compete very aggressively on price, forcing everyone else, including Tesla, to react.
It's turned into a global EV price war.
It really has. However, even with those compressed margins, Tesla still holds a pretty significant structural advantage compared to the legacy automakers trying to transition to EVs.
Which is what? They're still actually making money on EVs.
They are. That's the key difference. Tesla, even with margins down, is still consistently profitable in its EV operations. Contrast that with, say, Ford. In the first quarter of 2024, Ford reported losing something like $1.3 billion just on its EV division, Model E.
Using over $1 billion in one quarter selling EVs.
Right. So, while Tesla's margins are under pressure, they're still structurally sounder in the EV space than the legacy players who are basically subsidizing their EV efforts with profits from gasoline vehicles or just burning cash. Tesla remains the only major American car company consistently making a profit selling only EVs.
Okay, now we absolutely have to talk about those regulatory credits you mentioned, because historically they played a huge role in Tesla's profitability. Sometimes making the difference between profit and loss,
Yes.
right? But that's changing.
This is such a critical point and often overlooked or misunderstood. These regulatory credits, mainly zero-emission vehicle or ZEV credits in places like California and other states, they were a vital source of income for Tesla for many years.
How did that work exactly?
Well, regulations require automakers to sell a certain percentage of zero-emission vehicles. Since Tesla only sells ZEVs, they always generated far more credits than they needed for compliance. So they could sell those surplus credits at almost pure profit to traditional automakers like Stellantis, GM, Honda, who weren't selling enough EVs to meet their quotas. It was basically free money for Tesla, a byproduct of their core business.
And you said it was crucial for their bottom line in the past.
Absolutely critical. There were periods, like back in 2020, for instance, where the revenue from selling these credits, maybe around $500 million that year, was actually larger than their overall net income.
Wow. So without the credits, they would have reported a loss that year.
Correct. Without that high-margin, non-operating revenue stream, they would have been unprofitable in 2020 on a GAAP basis. It was a financial lifeline during key growth phases.
But now, as all those legacy automakers are finally starting to ramp up their own EV production, they don't need to buy as many credits from Tesla anymore.
Exactly. The need is rapidly disappearing. As Ford, GM, Stellantis, and others start selling more of their own EVs and plug-in hybrids, they meet their own quotas or get closer to them. They just don't need to buy Tesla's expensive surplus credits.
So that revenue stream is drying up.
Drying up very fast. The data shows a steep decline. From a peak of maybe $890 million in a single quarter back in Q2 2024. Forecasts suggest that revenue stream is expected to plummet, potentially hitting near zero by the second quarter of 2025.
$0 from regulatory credits.
Yeah.
After being such a significant contributor.
Effectively zero. It's a massive change to their financial profile.
So what does that mean for investors trying to understand the company's health? It removes a kind of artificial boost to profits.
It completely removes that distortion. It forces everyone, investors, analysts, to evaluate Tesla's financial health based purely on the profitability of making and selling cars and maybe their energy products. There's no more cushion from credit sales. And since we already know the car margins are being squeezed by competition, the complete evaporation of this easy, high-margin credit revenue puts immense pressure back on those core cost reduction strategies.
They have to make the 4680 cell work. They have to get the unboxed process savings just to maintain profitability now.
Precisely. Flawless execution on cost reduction becomes absolutely essential, not just for growth, but just to stabilize the core business and protect the bottom line now that the credit safety net is gone.
Okay, that's a really crucial shift. Now, thankfully for them, the energy segment, the Powerwalls and Megapacks, that seems to be growing rapidly and offers maybe some buffer.
It does provide a very important counterbalance, yes. The energy storage division is seeing really strong growth. Deployments hit a record, something like 12.5 gigawatt hours in just Q3 of 2025. That's a lot of batteries.
And is that business profitable? Are the margins better than cars?
Margins in the energy segment have generally been improving and can be quite healthy, especially when you factor in the recurring revenue potential from the software. Remember Autobidder and Opticaster.
Right, the software that optimizes when the batteries charge and discharge to make money.
Exactly. That high margin software layer, using AI to automatically manage these energy assets and maximize their economic value in real-time grid markets, that provides a really valuable stream of income and helps stabilize the overall business against the volatility and margin pressure in the automotive division. It's becoming an increasingly important part of the story.
Okay, but before we look purely at future growth, we probably need to briefly touch on some of the non-operational risks that seem to constantly swirl around the company, specifically around governance and key person risk. That definitely impacts the stock price, right?
It absolutely does. It's a factor that institutional investors especially have to grapple with constantly. There's a documented history here: securities, class action lawsuits, enforcement actions from the SEC, often related to, shall we say, controversial public statements made by the CEO.
You're talking about things like the funding secured tweet back in 2018.
That's probably the most prominent example. The tweet about potentially taking the company private at $420 a share, claiming funding secured, which the SEC later alleged was false and misleading.
And that led to settlements, fines, even requirements for oversight on his communications.
Yes, the settlement included financial penalties and mandated that certain of the CEO's public communications related to the company be pre-approved by legal counsel. Now, whether that oversight is always perfectly effective is debated, but the history is there.
So what does that history mean for the valuation? Investors have to factor in a certain amount of unpredictability.
Exactly. This context creates significant unpredictable volatility risk. And huge key person risk the company's fate and valuation are incredibly tied to one individual. Institutional investors have to account for this governance instability. It usually means applying some kind of discount to future projections, acknowledging that unpredictable events related to governments or CEO actions could materially impact the stock price at any time, irrespective of the company's operating performance.
Okay, let's look forward again. The next big thing on the product roadmap seems to be this next-generation vehicle platform. And it's really serving two distinct purposes, isn't it? It's not just one car.
That's right. This new lower-cost platform is designed to underpin both a mass-market consumer EV, the one often called the Model 2, aiming for that crucial price point around $24,000 or $25,000.
The car for the millions.
Exactly. And it's also supposed to be the foundation for the dedicated robotaxi, which they've sometimes called the cybercab.
And that cybercab is envisioned as something quite different. No steering wheel, no pedals.
That's the concept shown. A purpose-built autonomous vehicle, maybe just 2 passengers, optimized purely for ride-hailing. No human controls needed because it's designed for level 45 autonomy from the start. And the plan, at least publicly stated, is to get these into production sometime before 2027.
Now, focusing on the consumer version, the Model 2, the big financial challenge there seems to be the risk of cannibalization, right? If you launch a much cheaper car, don't you just steal sales from your own more profitable Model 3 and Model Y?
That is a huge risk, a very real danger. If the $25,000 car just pulls buyers away from the $40,000 Model 3, your overall revenue and profit could actually go down, even if you sell more total units.
So the success of that cheaper car depends entirely on it expanding the market, not just shifting it.
Absolutely. Its profitability is completely tied to whether that radical unboxed manufacturing process actually delivers the massive cost savings they're projecting. They need that lower cost base to make money at $25K. And the car needs to attract millions of new buyers, people who simply couldn't afford a Tesla before. It has to grow the total pie significantly, not just take a slice from the existing Model 3Y pie.
Okay, let's try to synthesize the whole competitive landscape as we wrap up. It sounds like they're fighting a war on two fronts against very different kinds of competitors.
That's a really good way to think about it. On one front, the hardware front, you have the relentless pressure from highly efficient, cost-focused manufacturers, especially out of Asia, BYD, NIO, XPeng, and others. They're driving the price war, forcing Tesla to constantly innovate on manufacturing just to stay ahead on costs.
That's the efficiency battle.
Right. Then on the other front, the advanced technology front, specifically autonomy, their broad-scale L2 FSD approach is being challenged by those specialized high-fidelity L4 players like Waymo and Cruise. They might be geographically limited, but they've actually demonstrated true driverless capability in those zones.
So Tesla's L2 everywhere versus their L4 somewhere.
Exactly. It's a fundamental difference in strategy and demonstrated capability right now.
So what does this dual threat mean for Tesla's core strategy, their total vertical integration? It has to deliver on both fronts simultaneously.
It absolutely has to. Their TVI model, controlling everything from silicon to software to factories, needs to give them a decisive edge in both areas at the same time to justify that massive valuation. They need to achieve unmatched cost efficiency through things like gigacasting and the unbox process to win the hardware battle against the BYDs of the world. And they need their AI stack FSD, powered by Dojo, to mature rapidly and safely, actually achieving that L4, L5 breakthrough to deliver on the robotaxi and Optimus promises, effectively leapfrogging the Waymos and Cruises in terms of scale and capability.
They have to beat the efficiency players and the autonomy specialists. That sounds incredibly difficult.
It is. They essentially have to be the best in the world at mass market manufacturing efficiency and the best in the world at deploying safe, scalable artificial intelligence and robotics. If they falter significantly on either front, the entire valuation narrative starts to unravel.
Well, this has certainly been a deep dive into a company making an absolutely enormous, almost existential bet on its own transformation. If we try to boil it all down, that $1.47 trillion valuation seems to hang entirely on them achieving flawless execution in two critical areas.
That's right. First, they need pure operational stability. That means getting those 4680 battery yields up, successfully scaling the unboxed manufacturing process, bringing costs down, basically shoring up the core automotive business just to survive the price wars and remain profitable now that the regulatory credits are gone. That's almost just table stakes now.
It's just the cost of staying in the game.
Exactly. And then second comes the really big leap, the technological one. They have to successfully bridge the gap from FSD being a supervised L2 system to being a truly unsupervised L4, L5 autonomous platform capable of powering a robotaxi network. And they need to scale Optimus production and capability according to those incredibly ambitious timelines. That's where the valuation premium comes from.
So for you listening, the story here isn't really about whether Tesla can design another cool-looking electric car. It's much bigger than that. It's about whether one company can leverage its manufacturing base and, more importantly, its data and AI capabilities to fundamentally redefine entire sectors of the economy, mobility, and labor. It's really an infrastructure and AI bet, far more than just a car bet.
And maybe the most critical unknown, the thing for you to really watch closely going forward. It might not be just about the technology itself. It's not just, can they build a working robotaxi? Or can Dojo process the data fast enough? Perhaps the biggest hurdle is actually building sustainable public trust.
Trust in the system.
Trust in the safety and reliability of these autonomous systems, specifically the cybercab. They're building this future on an FSD architecture that, as we discussed, already has a history of documented safety incidents, regulatory probes, and recalls associated with its L2 deployment. So successfully launching a fleet of fully unsupervised robotaxis isn't just a technical challenge. It requires convincing regulators, insurers, and the public that the system is orders of magnitude safer than it has appeared at times, that potential failures are incredibly rare, and that liability is clearly understood.
It's a perception and confidence challenge as much as an engineering one.
Exactly. How do they assure everyone that safety incidents will be prevented? How is liability handled when there's no driver? Answering those questions credibly might be harder than solving the final technical problems. And that hurdle, the regulatory and public confidence piece, could very well force a much slower, more cautious, perhaps more geographically limited rollout of robotaxis than the company's typically aggressive projections might suggest, regardless of when the tech itself is technically ready. That trust factor could be the ultimate bottleneck,